Good evening. I hope everyone still has energy at the end of this great day that we've been having. My name is Robert Carbone, and I will be talking about OpenRiak. Ideally, when I started, I wanted to, well, this is my 10th anniversary of Erlang programming. I started my journey back when I went to San Francisco for the first time, and I met Joe Armstrong. And Elixir was just coming out. Elixir was a baby girl at that point, and carried on a whisper to where we are today. And I had to make a decision. Was I going to take the almost easy road, so to speak, and just jump on the Elixir bandwagon, or I met Joe. If anyone knows him or got to meet him, he is a personality, was a personality. And I took the harder road because my thought was, if I went and did something hard in Erlang and figured out exactly where Elixir was going, I could then meet up with you all later. I could be like, okay, I was trying to figure out the right time to kind of tack into Elixir to bring something to the community. And I found, first I found WX Erlang, and I tried to do that, but a beginner programmer taking on a large C++ project, that was overambitious. And what was lacking there was actually a backend database to be able to do something scalable. And that's when and at that time, Basho was funding a lot of things, and I wanted to work for them, and they just went under. At that point, React got open sourced. So when I was talking to a lot of the Elixir people, I was going to come do a technical talk, but after talking to a lot of the Elixir people here, no one really knows what React is in the Elixir community, and how it works. And so I wanted to address that first. And let's first look at the main personalities in the room. There seems to be the beginner programmer who doesn't know what React is. They know Phoenix is good. They are like OpenRiak. Tell me about this tool. Tenacious. There is the veterans who have been through this for a couple years, who want to scale, or they've run into a problem. They have Cassandra, they have Mongo, and to some extent, they've been kind of sold a bag of lies saying it can scale, and they're running into problems, and they're looking for a better solution. And React is that solution. And then there's also the CEOs, the C-suite, that are looking at this tool saying, is this the right tool for my company? Is this the right tool that we can use to hit to overcome the next hurdles that we're facing, and save money on licensing fees, and look at the 2 to 3 to 5 year plan and save money in the long run, and save time in the long run, and be able to build on it and cultivate the unknown. Because when you have unstructured data, that's what you get. You get to be able to cultivate the unknown. You don't have relations. And in fact, that's kind of what I'm trying to teach you today, is to figure out how do we tie ourselves from the relations that maybe some of the predecessors have looked into. That's a challenge, because relations are comfy. It feels good to actually be able to say, oh, this is have structure. But the brilliance of Erlang is that it doesn't have, it doesn't need structure. In fact, if you start to look at, and this talk is going to go deep into math, and so I was trying to figure out how do I talk to the beginning devs. And so if beginners, if I say a word, you guys have AI now, go look on AI. I'm not going to lecture you on definitions. Just look this stuff up. This talk is my opinion of what we should be doing, so please take it as such. So I'm going to be jumping around and talking each one of those three groups, because there's no easy route into this stuff. I wish there was a linear route, but again, no structure sometimes is better. So there's three types of orders in mathematics. There's pre-orders, partial orders, and complete orders. Now, it seems most languages out there start with linear orders or tables. Basically, known, predefined, tupled, or structured lists. Erlang doesn't. Erlang actually seems to thrive off this idea of partial orders, and this is what gives us our power with the scheduler, because we have no order. The order is actually the causation of what messages we send, what signals we send. and how we actually how those signals propagate through our system. So this is a superpower. Other languages will look at this and be like, no, that's you need structure, but you don't, because it's more fundamental. It's more fundamental in the grand scheme of things. Forgive me as I try this new type of presentation. Now, so I think you saw Nicholas and Peter. So let's jump around. So back to the idea of Riak and like, what is it? So it's made up of three. When I got into this, you find out it's made up of three different main parts. It's KV is the foundation, CS is your S3 or file data store, and then at the very end of Bash's life, they attempted to add this SQL time series system to pander to the IoT people. It didn't work. And so unless you really need IoT stuff, well, you can use KV and CS. I would recommend going in that direction and exploring as such. When I started trying to hack at Phoenix, I had this idea, and we're still working on it. My goal today is actually to get a lot of you to help build what I think we need to build to hit the next level of integration between Erlang, Elixir, and at the very end, hopefully I get into the future beyond of what we're looking at in 2 or 3 or 5 years. I want to get you to help join the OpenRiak working group, which is just about to be formally formed. We've been working for about a year, and we're basically cleaning out all the things we need or we don't need at a very technical level. There's some wonderful individuals, such as Adrian Frehe and Martin Sumner, who talked earlier this year. If you guys want to hack at the Elixir client, again, I'm not going to give a purely technical talk here. Here's the link. I think you all know how to read a library and hack at it. There's 2 ways of talking to Riak. There is protocol buffers, and KV has an HTTP interface. You ask for the data. It's plumbing. Riak is just, I wish it was sexier, but it's reliable and it works and it scales. So I trust you can go hack at the client, and come find me every second and fourth Wednesday of the month around 5 p.m. EST. I want you to come. If you're really interested in helping add to this project, I'm looking for 4 to 8 hours from everyone in the Elixir community, because I don't know what questions to ask that Elixirists need. The more Elixirists I talk to and Phoenix framework individuals, everyone has a different need and a different set of tables. And the beauty of Erlang is the idea of behaviors and being able to abstract them. And so we need to figure out what order and exact patterns we need to abstract as a group, and we need to reorder that and attack things that way. The documents are up here, and how many people know what a distributed consistent hash ring is? Yep. Okay, so about half the room. The magic behind Riak, quickly, is that you have basically a RAID, a redundant array of independent disks, but it's at the application level in your OSI framework. It isn't actually at the lower level like RAID happens. It happens where you have multiple computers, Erlang, gossiping amongst each other, and they resolve eventual consistency, if you will, what data is current and up to date. And how many of you guys know what the OSI framework is? Okay, same group. Okay, those must be the hardcore devs, and this must be the beginners. So this is, for open source systems, this is your master framework of how all computers communicate. So if you haven't looked at this, Wikipedia this, AI this, you will grow very quickly if you understand how all these layers work together. Phoenix works up on the application layer on top of Erlang, and you can see we have other projects in Elixir and Erlang community like Nerves, which are working on the physical layer. One of the brilliant things and why you should learn OpenRiak is that it actually works kind of in between them at the network layer. For the hardcore devs, it's nothing but a thing to just go set up a bunch of Linux servers and have them talk and have the IPs and the sockets. For the beginners, this is something you should be doing. You should be absolutely focused on how to do networking correctly. In fact, even a couple days ago, Andre Leopardi came out with a new book. So this is a need in our community, is to actually get better at networking. And I believe that React is a wonderful case study for us to actually get better at this. And this is why you should be interested in React and coming to help join and to better yourself. I'll happily, anyone who comes, I want to pair partner program groups and give certain parts of the source code to look at so we can simplify it for the people to come after us. And I think if we wash, rinse, and repeat that a couple times, then we'll be there before we know it. In a way of communicating this stuff easier to the beginners and writing some necessary code with examples. Also why, be hard to destroy. It's, you definitely don't want to be tough to kill, but if we all have a React system and our data in it with an S3 database connected to a KV store, we're much more resilient as a community. I want to see any Erlang Elixirist who comes in the community to have this as a gift that you get for choosing Erlang Elixir. Now, one of the things that Joe would always say is don't break the rules of physics. He'd interrupt people right now. He'd be yelling if he was in the room. And so this is this is a light cone from physics. This is why Erlang works with preorders, is because the causation of light as it bounces amongst the different atomic particles and the signals are readmitted, that's what the speed of light is. So if we program in a way that we don't break the rules of physics, things just tend to work out. A saying that I had to kind of encapsulate this a couple years ago was that the future is functional, the present is mutable, and the past is immutable. This is brilliant because you can't predict the future, but you can write a function that will help tell you what we think something's going to be. And we have fault tolerance to be able to fail over if we don't have it. So we're not breaking the rules of physics here. Now, ways into learning React. This is pretty brilliant. The more I stared at how we teach this, there seems to be 4 different paths. And this is what makes React kind of difficult to, this is a huge barrier to entry that we're trying to overcome right now. But again, for a Linux dev, this thing is easy to set up. So we can either, create a Docker container and, which is, you can see this, that there's like this interesting L2 versus L3 phenomenon occurring between the way we horizontally or vertically scale. Where if we, horizontal adding is adding more computers or more boxes, where vertical scaling is usually adding more memory to a box. So if we add more virtual machines, then we're basically taking away the amount of resources in that, or we're partitioning the actual hard drives. With Docker, we're mounting, we're containerizing. So we're kind of getting a division aspect there, where if you learn, and you can see how those are 2 different skills. You might know how to do a virtual machine, you might not know how to do Docker, or vice versa. So these are your 4 different entries into learning React. Please choose and tell me what you're most interested in. Okay, so that brings us to the math, the heavy stuff here. So lifting is this idea of adding commutativity. In category theory, which I'm going to try to simplify right now. I don't want this to scare anybody because usually that's a swear word. But there's a very brilliant quiescent point deep in category theory that you should all know about, that after you hack at this for years and years and years reveals itself, and it's beautiful. It's this perfect duality in between what an OR is and what an AND is. And this is like the first thing we learned is, with binary, is like what are our basic logic. But this pattern continues deep, deep, deep into the category theory. And we can see this in our CAP, and this exemplifies the CAP theorem, which is, for those beginners, in databases, they say you can only get 2. You can either be available or have consistency, but you can't have both. So some groups of databases choose consistency. which is you end up with SQL-like things that are relational and acidic usually because the data has to be one container. And the opposite of that is you end up with something like OpenRiak, which ends up being more of this global, you don't have, the data is always available, but it might not be the most up to date. But with eventual consistency, the data will be up to date, usually in a couple 100 milliseconds tops. So that's what we're talking about with the speeds of eventual consistency. Which will play quite nicely with live view, so to speak. Now, in category theory, we call these limits and co-limits. And the, well, this is your compass. This is your orientation. It seems simple, but when you delve into category theory, I encourage you, please all, to go look at limits and co-limits as an ability to understand what you're doing. So for instance, a gen server, right? The definition is the greatest lower bound. So how high you can containerize like a gen server, for instance, because you have your specific module and your generic module, and they combined. And in that little state space, you have consistency. You have, all your data is really close to you. You can grab it, you can write it. We all understand that, I believe. This idea of adopting OpenRiak gives you the other superpower, which is what Erlang has given us, and why we all love it, is this idea of pre-orders that I told you in the beginning, alongside this idea of not breaking the rules of physics. It is inherent in our time warp system in our clock because of causal monotonicity. Causation and monotonicity being actually preserving, having a certain order and preserving that order allows us to actually send messages and so that the order is preserved. You'll see a lot of CRDT libraries, like even with Electric SQL, always putting the CRDTs at the top level. This is because of causal monotonicity. Riak is no exception. It does this as well, and this is what makes its CRDT library work. So this is very important because when you think of causation in any of your systems, this is an ability for you to use OpenRiak to preserve the causation in your, and preserve the order in your system. And it should be coming from your global database space. It shouldn't be coming from your meat. I see so many people trying to preserve this at a lower level. The math says opposite. And this is what I mean when I say this will orientate you. Because this, and this is, I think, the most important thing, is as abstract as it is from this talk, is that you can orientate yourself in these deeper mathematics. So I encourage you all to look at, use AI, look deeper into this, and you will see it when it pops up in your software, and you'll know, oh wait, can I use Riak? To the CEOs, this is an ability for your team, and the C-suite, this is an ability for your team to look at designing causation into your system. Like for example, finite state machines, they have causation, so they have order. As long as you keep and predefine that kind of order, then a finite state machine is completely fine at the global level. For instance, like a form, right? If you or let's say you're trying to get money from a bank and there's a number of steps that happen in order, you could make that as a conflict-free replicated data type, is the heavy term here, again, AI. And this is the right place to do it. So that is the and the order and the ability for that to occur comes from this idea of lifting or commutativity. Commutativity means that the order of how things are added, or the order of operations or operands, does not matter. We've all learned this, I believe, in 6th grade. So a CRDT works as such, where you're able to merge at a global level the state space, or if you're using an operation-based CRDT, it helps you merge the actual operations. And so this is what's ahead of us for the Erlang Elixir community. an ability to actually utilize OpenRiak. And as dry as it may sound, as dry as plumbing is, it's reliable. And if it works, we get the miracle of water. We get the miracle of the ability to scale ad infinitum, as long as we preserve our causality. So I invite you all to join me again on the second and fourth Wednesday of the month, or join the EEF working group, please, to we meet on the first Wednesday of the month, and come check it out. If this stuff seems of interest, if you're looking to hit the next level of scaling and your current database doesn't serve you well, please come help out the community as we grow and bring this to the rest of the Erlang, Elixir, and Phoenix ecosystem going forward.
Thanks, Robert. Does anyone have any questions? Yeah, we have one.
Actually, I'm quite new to Elixir, and I heard of OpenRiak the first time yesterday. What is the current state? Can I just use it with Ecto, or yeah, can I just use it as a replacement for an SQL database, kind of? Or do I have to remodel my whole application to match that?
Well, use it with Ecto. You wouldn't want to. That's the point of I was trying to go into here with this idea of limits and co-limits and this duality, is that running a hybrid system is the way to scale your application when you really need to add on lots of data or lots of users because of its ability to be eventually consistent versus trying to carry around this large state space. You want both. I mean, you want to be able to use your SQL system, I believe, theoretically for, mutable data and when you're beginning, but then over time slowly think about the things that don't need causation that you can kind of pull away and turn those into more of a key value store. I think you already probably do this innately with maps. I mean, I hope everyone has messed with tuples and maps at this point. So you kind of know when you need to use a map, and you kind of know when you need to use a tuple and when data is connected and when data isn't connected. The idea of an and is actually a restriction because you need two things. And needs to this and this versus an or is more of an opening expansion to be able to disconnect. Yeah.
For me, it's more like a question of how easy is the modeling, and how do I think about it. It's often nice to create a model like an actual thing to then express my domain. And if I'm completely losing that, just to have like only structs or something, and then have this whole other model, this would be a huge shift of how I use the language and the ecosystem at the moment.
I mean, the short answer is it depends on your data types and exactly what context and domain you're in. I mean, for data types that you want to be highly correlated and highly bound and are going to be need to be consistent at a low level, absolutely use that strategy. But the other, you always want things to be quick and fast. But I mean, React is absolutely fast enough if you use it and you try it. It's more than fast. In fact, it surprises most people how fast it is because they're usually used to other NoSQL systems not being as fast. I'd love to take 10, 20 minutes going on bucket strategies and how do you use different buckets and when do you use different buckets. It's a different talk exactly for data strategies in that way.